Well, as you can see, I'm here alone at my 3D print farm after hours, hard at work. Gets lonely sometimes, but I've got my music to keep me company. This video is going to be a little bit different, so I'm going to give you a preview of what's coming. First, we're going to talk about the Arduino board and how the Arduino board is going to be integrated into my 3D printing for upcoming products that we'll be selling on the website. Also, we're going to look at some problems I've had with filament, and as you can see, this is degraded terribly, and I'll explain why. Also, my music sometimes gets the best of me, and I have to let my hair down. So, rock and roll, go old man, go. And then last but not least, we're going to talk about some stuff that we have to do out at the print farm, some of the physical work. And last but not least, here is my grandson. Finally, we get to take a look at him, and you can see him doing some soldering for me. And as you notice, he uses the helping hand also to hold these resistors in place as he's doing the soldering. And with his young eyesight, he doesn't need magnifying glasses or any kind of aids at all. So I really appreciate all the work that he's done and the way he's helped me out, especially when it comes to these tedious jobs of soldering. And it looks like he's got that one finished, and we'll go on to a final assembly of several more. So let's get started with Arduino. Okay, I want to show you one of my favorite little pals here. If you notice this, it's an Arduino board. And for any of you that aren't familiar, we'll just open up this little guy. And there he is. Little Mr. Arduino himself. And what this is, it's a microprocessor that is mounted on a board that provides I/O capabilities, basically has a place for power to come in. You can connect it to your computer. You can download free software for the programming of this thing. They call the programming sketches, and a sketch is just a bunch of lines of code that or instructions that tell this board what to do. Now you can see the size of it. It's very small, fits in the palm of your hand, but it's a very powerful little processor. It runs at a pretty good speed. It can take inputs from different sources, analog as well as digital, which means that you can have a push button switch, and every time you push that button, it gets one input. Or you can have a photocell or something that the more light that goes in that photocell, the more it's going to change the resistance of it and cause this thing to increase in voltage or decrease and give you an analog type input. It can also control stepper motors. It can output to displays, liquid crystal displays. You can have keypad inputs and so forth. You're going to see a lot more of this little board in action, because before I got into 3D printing, actually 2 years ago, I've been doing this now for 2 years. But before that, my plans were to work with electronics and experiment around with electronic circuits. And when I got the idea for the helping hand, then I got a little distracted from that and focused my attention on 3D printers and what I could do with them. But now we're going to merge the two. And the first project, I have several projects in the works or in the planning stages now that will use a microprocessor board. And with the products that I'm manufacturing using 3D printing. But the first one that we're doing right now is the filament counter, and I've done some videos on that, and I made one that was semi-automatic. It had a digital counter and a wheel device that it would go through, a counting device where it would automatically count pulses and would determine the length of filament going through that device. I was using a hand crank to actually pull the filament off of the source spool onto the slave spool. With the use of this process controller, we're going to eliminate a lot of the steps that I have to go through with that manual filament counter, because it will have a motor. You just right now I have to calculate how many pulses I need to spool off 24 or 42 meters of filament. This computer will do that for me. It'll do the math. All I have to tell it is how many meters do I want. 44.5 meters. And I punch in 44.5 and that's it, and go. And it will automatically calculate how many pulses it needs. It will automatically start the motor and gradually bring it up to speed. And then as it nears the end of that count, it'll start automatically slowing the motor down so that it won't have to do an abrupt stop when it gets to the 44.5 meters. And it will stop at that point, and then all I have to do is cut the filament, take that slave spool off, and put it on the printer that it's going to run on, and it'll go from there. So the little microprocessor board is going to have a lot to do. Okay, I've got a Tronix CXY2 Pro here. Last time we ran it was back before Christmas, and we had some orange filament left in it, and it never was taken off. Looks like we had about 28 meters of PLA that we had spooled off for this job, and didn't finish printing for some reason. And then I came in here and noticed all of this filament, and if you look at the spool, the filament is just disintegrating and coming off of this spool. So you can see it's like spaghetti. So I wanted to show you that because we've had conversations about filament and moisture in the filament and so forth. This one is a good example because you can see how it's disintegrated. There's a little bit here left on the spool that hasn't degraded to that point yet, but all of the rest of it has. What caused this? I assume that since originally this spool had 28 meters on it, if I remember correctly, the print failed after printing about 8 meters of it. So this is about 20 meters of filament. If it had been taken off and sealed, it probably would have been in much better condition, obviously. But when this stuff breaks to this point where it's that brittle that it just snaps like spaghetti, you know that you've got a problem with your filament. You don't want to try to print with stuff like that. So I'm going to have to move these printers out of the way and get this mess cleaned up. To give you a little background on this filament and why this happened, this particular source spool of this filament was one of the 20 two spools that I opened back when I first ran a test on 22 of the Anet printers down here at the print farm. And if you go back and look at the videos, you'll see that that was 6 or 7 months ago. So the original spool was opened about 7 months ago. Since then, we have used some of it off of that, and it's been in a vacuum sealed bag with silica gel and so forth, but it's been in and out because I would bring those spools out and print some stuff on them and then put them back. That was before I came up with the filament counter. Now once I got the filament counter, I started taking those spools of orange PLA that had already been opened and using spooling off portions of the remaining filament on those spools for different print jobs down here, which is what I was doing on this one. But as you can see, once it was left on the printer here for, let's see, that would be about a month, maybe a little bit over a month. It's been on here since almost Thanksgiving, if I remember correctly. So in that period of time, the remaining filament on this spool has completely degraded and become as brittle as raw spaghetti. The humidity in this area usually runs about 38–39%, but it's usually 40% or less humidity. So we don't have a tremendous amount, but still this filament was able to absorb enough of it to completely degrade. Now I think what happened was that it always seems to absorb moisture at the cut end, and it absorbs moisture up through the filament. There's apparently some type of coating around the exterior of the filament that gives it some protection. So unless there's a nick or a scratch somewhere on the filament, that moisture will come in the end. And I believe what happened here was that the end absorbed moisture, became brittle, broke off and fell down. Then the next 2 or 3 inches absorbed moisture, got brittle, and fell down. And it kept doing that over and over and over till it worked its way through all of the remaining 20 meters, with the exception of this little bit right here, which this is not brittle yet. The tip of it is, but a little bit of it just hadn't quite gotten to that point. But that can happen, so that goes to show that you do need to pay attention and protect your filament. And it sometimes will have something to do with the filament itself, I believe, as far as how much moisture it will absorb and how old the filament is and how long it's been since it was originally opened. Because once these spools of filament, once the filament absorbs moisture, it can't get rid of it unless you take the entire spool and put it in some type of a dehumidifying oven and essentially bake the moisture out of it. I saw this mess over here, and before I cleaned it up, I thought I'd show it to you and give you another example of some of the things that you might eventually run into. Okay, here I am alone at the print farm. And as you can see, I'm hard at work, content, listening to my music. Of course, I can't play the actual music because of YouTube policies. But the next song that'll be coming up is a favorite of mine called Moni Moni by Billy Idol. And as you will see, I kind of get into this song Kind of gets my blood pumping. Finally getting some exercise. Okay, all you young fellas out there, watch this 74-year-old. You might pick up some neat moves. I never thought I'd make a fool of myself on YouTube, but what the heck. Had this camera, one of the surveillance cameras, and was going back and reviewing some tape and saw this video and thought, well, why not share it? Maybe somebody will get a kick out of it. Oh Lord, now he thinks he's got a microphone. Watch out, world. Well, I think we've already burned off about 2,000 calories here. Well, I guess as long as he can do this without having a heart attack, we'll let him have his fun. Eventually the music slows down and the old man will sit down and get back to work. Ride that pony, boy. Okay. I think that's about enough. I don't think we can stand anymore. Let's sit down and go back to work. Finish out that lonely night shift. Okay, we're down here at the print farm. We'll show you a little bit about what we got going on today. Down here we're printing these 40 of these little clips. These are the little wire clips that go on the table mount helping hand. And right over here next to it we're printing these vice clamp adapters. They have two threaded ports for flex arm accessories, and then the vice clamp actually connects here. And right around behind us here on the new PEI sheet, we're printing in PETG some of the base for the table mount helping hand. And let's see, moving back around here again, on this ET4 with the PEI sheet, we're printing more of these for the filament counter. I'm going to print about 20 of those so I can assemble 20 filament counters and put them on the website and see what kind of demand we have for those. And over here we're printing the rod ends for the table mount. And back around down here we're printing the tall, these pieces right here, and that job will be running for about 34.5 hours. And We'll be printing 6 of those. Over here, we're going to be printing 4 of the, got it mixed. These are 4 of the tall parts. These are 6 of the flood adapters. The flood adapters. And up here we're printing more of these power box covers for the helping hand. And up here we're finishing off, we're printing our last batch of these filler parts for the helping hand. And that should finish off this roll. It looks like I've got just enough left on the roll to finish that. So that's basically what's going on down here right now. And thought we'd just give you a little update. Again, it's all me by my lonesome. Cry for me, Argentina, I guess. But anyway, I've got a lot of other parts. I'm going to have to print some more of these feet for the holders. And down here, you see these steel rods. Those steel rods, I've cut them, but I haven't deburred the ends, so I have to take them out in the shop area and take the grinder and grind the ends smooth. And then once I do that, then I'll clean them, and then we'll take them out and paint them, and then they'll be ready to be assembled. So this is kind of what's on my agenda right now. We're also going to be printing some lap diners up here on the top shelf a little bit later this week. This is Monday, so I'm just now getting things started. And then I've got some, actually put together another ET4 over here with the PEI sheet on it, so I'm going to get it up and running. I'm really checking these spring steel PEI sheets out, putting them through the test, running both PET-G like I am here, PLA here, and right now we're running PLA on this one. I'll get that other one up running, probably some PET-G parts on it, because I wanted to see how the adhesion is with both types of filaments, since those are the major ones that I use, and also see how they print. So far they've been doing a pretty good job. So until the next time, happy printing from New Tech Inventors.